Hello, everyone. So my name is Koleva. I'm part of the product team in Databricks. And this session is about external models. I just want to see some hands. Who's interested in the Azure implementation of those? Connecting to Azure, all right. Connecting to OpenAI models. Okay, more Azure users. All right. AWS users, Bedrock. Okay. All right, I'll show you all of those. So this session is about all of you that are leveraging models from different providers, be it Meta Llama models or the Claude Anthropic models, OpenAI, et cetera, or a combination of those. I'm going to show you what is supported in Databricks. I'm going to show you how to deploy the endpoints, how to query them, and we're going to talk about the best practices around observability, around secure deployments, and then we're going to see how you can compare between different models and do A/B testing between them just to see which one is the best for your use case. So why this topic is important? The thing is that there is a new model crashing the benchmarks every week. So the world of GenAI is changing very rapidly. At the same time, we get models that are performing as well at a lower cost. So being able to very quickly get to those models and implement them in your use cases is quite important to stay on top of innovation. The second reason is that being highly dependent on a single vendor puts you in a position of, being very, very exposed to cost fluctuation, backwards compatibility issues, and so on. So basically leveraging models from across providers allows you to hedge against changes in the market and being able to be more portable no matter what model comes out next week, being able to swap between those. So you might have been in a situation where you're looking at all of those providers and you're wondering what to use. There's a lot out there. Some of those models are good for one use cases, but not as good for the other. How do we navigate a world like that? I pulled out some benchmarks recently, and this is just to show that there's no one-size-fits-all. There's not one big model that is trained on all the data out there and performs very, very well in everything that you need it to do. You can see that, for example, Grok models over here are performing very well at reasoning. And then the Claude models are very, very good at agentic coding assistance, so they might end up being the choice for those use cases. And the Llama models are very good at tool use. And this is just to put things in perspective that in your organization, with all the different GenAI use cases that you will find yourself building, you're going to need a different model for each of your use cases, all right? And in a world where you need to navigate all of those vendors, all of those different models, what are some of the things that you need to consider? So the first thing is being able to achieve high quality. And what you find yourself needing to do is just provide your team with optionality. All of those models, as I mentioned, change week over week. And there's new cost profile models coming out. There's new models that will give you lower latency at the same cost, et cetera. So being able to get all of the optionality to your teams is very important. And even more importantly, giving them the tooling to evaluate those models against each other and choose the best one for the job. So you may find yourself choosing Claude models for code assistant, but for your content generation marketing campaigns, it might be that a fine-tuned Llama model is better. And for some of your more complex tasks, it might be that a GPT model that can reason over tools and perform this sort of deep research capabilities might be the choice. The second thing is standardization. My clock is not moving. I don't know, doesn't matter. So the second thing is around standardization, which is needing to access those models in a standardized way across their versions and across providers. You may think of an organization that has teams A, B, and C, which are trying to make use of, let's say, Amazon Bedrock and Mistral and Gemini models, and maybe some models are on Databricks. And it might be the case that, let's say, Team A is authenticating to Gemini models through their Google Cloud project, and that's how they're reaching those models. And maybe team B is leveraging API keys to Mistral while actually authenticating to Amazon Bedrock with their AWS Access keys, and maybe even sourcing some open source models from Amazon Bedrock. And maybe there's team C that is actually authenticating through Databricks and is getting to those models from our integration with Google Cloud. So what you can see over here is that we're just looking at a lot of inconsistency of how they reach those providers. There's a lot of inconsistencies between the code bases, so it just means that collaboration becomes very, very difficult. Knowledge transfer becomes difficult, and creating reusable assets that are used by all of these GenAI paths and workflows becomes nearly impossible. So in an ideal scenario, you're basically looking at all of those teams standardizing the way they're reaching model vendors, no matter who they are. Now, the third thing is governance, and it kind of comes with this standardization, but in an ideal world, you want to govern who has permission to what models. You might have one business unit that is dealing with highly confidential data that you're only comfortable exposing to certain providers, while others you can get more permissive. So being able to govern who can access what in a central manner is very, very important. Being able to manage credential keys, we've all seen those unfortunate situations where API keys get exposed into the code base. Is something you want to avoid with managing multiple API keys to multiple model vendors. And applying guardrails as a central team, for example, imposing the guardrail for PII data masking across your organization, or applying safety for content guardrails across all of those teams. So you might be looking at a setup where all of those different teams actually make use of a centralized system where you can apply those guardrails, when you can do fine-grained permissions management, do credentials management, and apply the guardrails in a single location. And the fourth thing is observability. With all of those vendors, with all of those activities, and we know in the future there's going to be more and more of those, we want to know who is using what are they calling, we want to log everything, we want to know how these models are performing from a quality standpoint, and we want to know how much we're spending on all of those vendors. Maybe you have budget controls that you want to implement on a team-by-team basis, so having the observability and being able to associate those budget controls is what we're after. So we spoke to a lot of customers about all of these issues, and last year we released Mosaic AI Gateway, and as of Summit now, it is generally available. So what is Mosaic AI Gateway? Mosaic AI Gateway introduces production readiness capabilities on top of all of your endpoints that are served on model serving. And when I say all of your model endpoints, what we mean by that is all of your Databricks hosted endpoints, so your Python models, your foundation models, etc., but also what we call external models. And external models are secure connections to models that are served outside of Databricks. So think about your Azure Foundry deployments, your Amazon Bedrock deployments, maybe a GPT model, right? So all of those providers. The other type of endpoints that we serve on model serving are agents and chains, which is an endpoint that contains a system. So Mosaic AI model serving, providing all of those endpoints, and AI Gateway sits on top of that, and it provides you with fine-grained permission control, guardrails, being able to do rate limiting, being able to do usage tracking, observability, and so on. And I'm gonna show you all of those capabilities. But it sits on top of model serving on all of those endpoints. And you can see where the value is, because now you have one single location where you can impose all of that governance on basically any model, no matter if it's on Databricks or if it's somewhere else, because you have that linkage. So yeah, this talk right now is more about external models. So I'm going to dive a little bit deeper on what we support there. So the first level of support, we call it the native first-party supported models. is from providers Databricks, Anthropic, and Meta. And when I mean native support, you don't need to bring your API keys. You can just start calling those models in pay-as-you-go manner or provision throughput, just straight from the platform. The second level of support for all of these providers is integration. It's integration that means you are providing the associated authentication keys to Databricks. You might be doing this through Databricks secrets, and you configure those when you're creating the endpoint, and we will securely then call those providers. So for AWS Bedrock, for example, that would mean bringing your AWS access key, secret access key, and for OpenAI and Azure Foundry, it would mean bringing your API key, and I'll show you in a minute. And the third level, and this is something that we released recently, is custom providers. So basically, any other provider, as long as the API schema is Open API compatible, you can now set up a custom connection to your favored model vendor. And you can register that as an endpoint in Databricks. The other cool thing that custom providers now unlock is custom gateway integration. So all of the challenges that I mentioned earlier, a lot of you actually started encountering those months ago, and a lot of you actually build your own AI gateways. And they may look something like this. You have a gateway that propagates your traffic to maybe OpenAI, maybe you're using some open source models, or you have custom models on Databricks, and you're doing some rate limiting, or you're just doing it for governance purposes. Now with custom connectors, you can chain the Mosaic AI Gateway to the custom AI Gateway, and you can make use of additional capabilities. For example, you can expand to other vendors or clouds that you didn't have access to before, and you don't need to build those in necessarily in the DIY manner in your custom AI Gateway. And obviously, you can leverage other out-of-the-box capabilities that Mosaic AI Gateway has that might not be in your custom AI Gateway for now. So we're quite excited for that. So I'm going to jump into demo to show you how to do the connections to all of those providers, and we're going to compare the models in Playground. All right. So the first thing that I did is that this is the OpenAI dev platform. I generated some APIs keys here. I also have an Azure Foundry deployment. I just chose one of their models. I chose the Phi 4 model, but you can deploy basically anything. And I have the APIs keys here, and I have the URL that I will need to call this deployment. And I have a Mistral API keys as well, just for demonstrative purposes. So I have my Databricks notebook over here. What I did before this demo is that I configured Databricks secrets. I created a scope, and I created secrets inside that scope that has those API keys that I will need for the configuration. This is just so that you don't expose your API keys in the notebooks. Then I have my MLflow deployment client. And here, and I hope it's big enough, we're creating an open AI connection. We're creating an external model endpoint that is pointing to OpenAI. And it's very, very easy. We have the MLflow deployment client. We're doing .create endpoint. And under serve entities, we basically have external model. We have the ID of the model, which this one is GPT-401 mini. And we have the OpenAI config, which is stored in the secrets. And that's it. That's how I've now created the connection to OpenAI, and I can use that OpenAI model anywhere within Databricks. So I've also done this for 3.5 Turbo, which is a completions model. It's, again, going with the OpenAI API keys. To show you how to do this with Foundry, I show you my Phi 4 deployment. Actually, Foundry is done through a custom provider connection. And for custom providers, you need to provide the custom provider config. And here I have the URL and the token. So this URL is actually coming from over here. You copy this. And the token, so the API keys, is coming from over here. It's very, very easy. You just need to copy those over. And now I have a secure connection to that particular deployment. For Amazon Bedrock, how it's done, it's an external model. I'm connecting to Claude 3.5 Sonnet. And for configuration of authentication, I have Amazon Bedrock config, and I have my secret access keys and the region of the deployment. For Mistral, very similar to Foundry, I basically have external model. It's a custom connection, and we provide the URL and the API keys. And here I'm deploying medium model, and here I'm deploying the 8B model. All right, so this is how it works from code, and this is the UX. It's very, very simple. When you're creating a served, entity, you can just use the UX for this, right? You can see the Databricks deployments, but you can also see the external models, and you can just start configuring those and enter your keys from here. All right, so I run this, and now I have all of these endpoints, and now I have 6 endpoints which are securely pointing to all of those providers, and I can start querying them. So let's see, we can open the GPT-4o1. You can do this super simply through like the query interface and just send a query just to test if it's working or not. We're just asking it what Databricks, it's giving me an answer, awesome. The other thing you can do is through a Python client. So over here, I have an endpoint. I have a client, model MLflow deployment client, and I'm doing client.predict. And I am just putting the name of the endpoint and sending the inputs. 4.1 is a chat model, so the expected input is in messages. But if I was to query a completions model, and 3.5 Turbo is a completions model, this is how the input would look like, but it's basically client.predict as any other endpoint. The other cool thing is that all of those models can be used like a normal Databricks model, and that is that you can use them for batch inference, for example. So here I have DB-SQL query, which is calling an AI query function, which is the way we perform batch in the DB-SQL context. And I have the endpoint name over here, which is GPT 4.1. And what I've run over here is the first column being some articles that I got from an open source data set, and I'm performing a write me a 3-sentence long summary and the highlights of this article, and I'm applying this on a batch, within batch. So you can just swap the name of the endpoint to your Databricks Llama deployment, or it can be your Bedrock deployment, etc. It's all very standard. It's just the name of the endpoint, and you can swap them. I also wanted to show you Playground, where we have the split screen with all of the different providers, and we can ask them anything. What is there to do in SF? And I have the OpenAI model next to the Mistral model, next to the Claude Sonnet 4, which is a Databricks natively provided model right next to each other. So you can start comparing each of those. All right, so what did we do? So the problem that we used to have in the organization, where every new provider used to take weeks to support, is now very, very easily solved by establishing connection to all of those providers in a consistent manner, and then being able to query them in batch with Python, SQL, etc. All of it in the standardized way. There's very, very easy to do this across the organization, because now we have a standard query interface across providers. We're no longer in this inconsistent scenario that I showed you earlier. And the other challenge that we've heard from customers is that changing a provider typically involved changing a lot of the client code, because different providers would have different behavior and would expect different type of payload. Now this is no longer the case. It's basically a one-line change of the endpoint name, and your client code can stay the same. So you can swap models very easily, no matter how the market develops. And what used to be a very, very difficult way to compare models, because they were all exposed in different interfaces, now you can leverage playground, as we saw, to actually do this side by side and see how they differ. All right, so you might be wondering, okay, it's very cool that I can do a vibe check on Playground in how those models are different, but what if I want to have some sort of quantitative comparison between those models? I want to make an informed choice of which model is better for my use case. So I'm going to show you this now. I got a data set from Hugging Face. It's the same data set I showed you for batch. It basically has a column with articles from CNN, and it has one column for highlights. It's like 3-sentence highlights of what this article is about. I took this one, and we just have it as a delta table. I'll show you what it looks like. Let's go. All right. So yeah, we have articles, and we have their summaries on the side over here. So what I've done is, I'm going to use all of those endpoints that we have, well, actually a couple of them, but I'm going to use several of those models in order to try to generate a 3-sentence summary of the articles. And then what we're going to do, we're going to compare how good the summaries are against the ground truth that we have from the data set here. So we're doing this through batch over here, which is basically applying AI query with all of the model endpoints, generating a 3-sentence long summary. And I've saved this into a delta table, so we basically have all of the responses. So you can see we have the Llama 4 responses. For some reason, they all start with, here's a 3-sentence summary. We have the OpenAI responses, 3.5, and we have the Mistral model responses over here. I saved this as a table, but if you have inference tables enabled on those endpoints, you can actually find those payloads into the system tables. But this is easier to visualize. So we have all of these responses. So let's start to get some quantitative idea of how we're doing. I have this notebook over here, and we're going to do a very simple data science comparison. We're going to get the RUR scores and the BERT scores that are just commonly used for evaluating how good a summary is. Over here, we are, let me zoom in, we're importing the libraries. We have few functions that are basically just computing the scores. We're loading up our table, and we're evaluating and we're logging those as MLflow runs within a single experiment so that we can use MLflow interface to compare all of those scores from the different models. And we're running this for Llama 4 Maverick, OpenAI 4.1 Mini, 3.5 Turbo, and the Mistral Medium and 8B models. This is very, very simple evaluation. You can do all sorts of, you can do custom logic on how you're doing this. Or you can even use agent evaluation, LLM judges on it. So once we run this, what happens is that I have all of the runs with all of the different models. And if we see on the graphs over here, I can start comparing the BERT score, the RUR score, etc. All right. So we didn't speak about governance, and I want to take some time to also show you how AI Gateway can allow you to do this. You can imagine how difficult it is to actually impose PII masking and guardrails across multiple vendors. So what we've done with AI Gateway is to provide you a consistent way to do this, and I'm going to show you in a minute. The other thing is we heard from customers that a lot of times they are hitting certain quotas, limits with, let's say, their GPT deployments, and they required a fallback strategy. So let's say you're hitting your GPT model, you're hitting the limit, and you want to fall back to, let's say, a fine-tuned Llama model. So something we're doing with Gateway as well is this fallback capability between providers that wasn't otherwise available. And the last thing is the general observability. So all of the endpoints that are Databricks deployed endpoints or external model endpoints, they are all basically subjected to the capabilities that are available to a Databricks native model, which means inference tables are active. You can see usage tracking, you can see payload logging for all of those models, and you can build observability dashboards on top of those. All right, let me show you. All right, so I have this FI deployment, and I want to enable those governance features on top of it. I can just click Configure Gateway, and I can get all of those capabilities over here. So I'm just going to go through them just to tell you what's what. Enable usage tracking. This is going to allow me to get the metadata about the usage on this endpoint. Enable inference tables would then create a system table that is going to log the inputs, payloads, and what the model produced, and we're going to unpack this for you. So then you're going to have delta tables about everything that is happening with all the predictions that your models are producing. And what's really cool about this is that now it's a delta table that you can start to monitor for. Let's say there's a quality drop. Now you can put alerts on the difference of values in that delta table, and alert anything downstream to do root cause analysis on your model because things are going south. Then there's AI guardrails for your inputs. We have content safety filters and PII detection, and same for your output as well. We have rate limits, and rate limits can be done on a per user or per endpoint basis. Why are rate limits important? Well, a lot of you might be thinking about rate limits for cost and just availability reliance. And the fallbacks that I mentioned earlier. So the fallbacks, the way they would work is you would need to have multiple served entities on the endpoint. And when we start getting 409 or 500 error codes, we will basically start falling back to the other served entities within your endpoint so that your service is still active. All right, so this is how you enable them. I've already enabled them before that on the GPT-4o. You can see how those, let me zoom out a little bit. You can see how those look like in the console. And you can see under inference tables, we have a delta table within the catalog with all of the requests that we're getting. And you can see, like the request messages and the responses, etc. So this is basically something you can enable for any of those endpoints. So you can now do centralized observability no matter how many vendors you're using under the hood, because we're treating all of these endpoints the same. So you can imagine building observability dashboards on all of the delta tables that capture the payload from Bedrock, as well as OpenAI, as well as your Databricks hosted models. So, we're aiming for this sort of like standardization on top of the model vendors. All right. So, just a summary of what we covered is that within Databricks, we can securely allow you to connect to all of those providers. There's more coming very, very soon, so tune in tomorrow. I've left the QR code for the gateway, so you can read more about it. And just a reminder of the challenges that we're solving here. High quality, we're trying to give our developers the widest optionality of models possible. Standardization, we're aiming for them to reach those providers as coherently as possible. We're trying to do centralized governance through AI Gateway with guardrails, fine-grained permission management, auditability on everything. And observability, we're now able to do observability in a standardized way on all of those model providers and build dashboards as a central team. So yeah, thank you very much.